Okay, welcome back. Year 11s, do not watch this video until you've watched part 1 on electrolysis. It will not make any sense and you'll just get confused and then you'll cry. Okay, so we're going to make it a little bit harder because, well, you know, it's chemistry, why not? So we're going to look at this idea of preferential discharge. Please remember positive anode, negative cathode. And also remember, please, positive metals and negative non-metals, with our one rule breaker of hydrogen being positive. Okay, so let's look at an example here of the electrolysis of copper sulfate solution. You'll notice here I've got an 8, which means I've got the oxygen there, so you can just see there that I've got the sulfate. Now that will stay a sulfate. That oxygen will not separate off and go to the positive anode. It will stay as sulfate. And you'll notice also I've got solution, which means I've got water, and there's my water there. So you can see my little compounds there. So where do we start? Well, let's start at the cathode. So the cathode is negative. You notice I'm pausing. I have to think about this. I know if I rush this, I'm going to get them the wrong way around. I am truly hopeless at positive and negatives. What's attracted to the negative? There you go. The negative cathode. Well, opposites attract. So I will have my positive copper and I will have my positive hydrogen. I've got 2 ions attracted to the cathode. What will be attracted to my anode? Well, it's positive, opposites attract. So that will be my sulfate and my hydroxide. I'm hoping that so far makes sense. Now, only one element or ion will be discharged at each electrode. Only one, ever. And it's always the least reactive element or the least reactive ion of the 2. So the least reactive negative and the least reactive positive. Now, you do not need to know this, but because I can't leave anything alone, I kind of really want to explain it to you just so it makes sense, so you can understand why it's the least reactive. But don't panic if you don't understand this bit. So I want you to imagine I've got my, I'm going to do the anode here. So I've got my anode and I've got that, so I've got my negative sulfate and I've got my negative hydroxide. Now, they are currently being attracted to the positives with an electrostatic attraction. And you'll notice there that the bond or the force of attraction between the copper and the sulfate is stronger than the attraction between the hydrogen and the hydroxide. So then I turn on the electricity. Honestly, turn on the electricity. I know, got some more buttons to press. There you are, I've turned on my electricity. Just a small amount, it's not going to do anything. It's not enough attraction to attract them away from their other positives. I turn up the electricity, haha. Okay, I have a strong attraction now. Now both are going to be attracted to the anode, but which one do you think will get there first? Well, it's going to be the hydroxide, isn't it? Because there was less holding it back, if that makes sense. And so it will reach the anode first and it will appear, it will be discharged. And the sulfate never quite makes it. It's always kind of pushed out of the way by the hydroxide. And this is known as preferential discharge, okay? So again, if that doesn't make too much sense, just remember it's the least reactive element, okay, or the least reactive ion. So let's have a look at it in a slightly different way. Now notice that arrow is the ease of discharge going down. So the easiest thing to discharge is at the bottom. That's the least reactive. So the anode, I had the sulfate and the hydroxide. If I look at those 2 there, I can see my hydroxide is less reactive. It's easier to discharge. And so it's discharged as oxygen. We will come back to that in one moment. So I'm going to get oxygen at the anode here, and the sulfate will stay in the solution. At the cathode, I've got my copper and hydrogen. I'm going to look at my little table there. I can see copper is less reactive, and therefore I'm going to get copper discharged at the cathode and hydrogen stays in solution. So let's work through that process physically. At the cathode, always start at the cathode. I've got copper and hydrogen. And if I'm looking at my series, copper is less reactive. Copper gets there first. Copper is discharged and the hydrogen never makes it. The hydrogen stays in the solution. as part of the electrolyte. At the anode, I've got the sulfate and the hydroxide. The hydroxide is less reactive. Up we go. The hydroxide is discharged as oxygen. I'll come back to it in a second. And you'll notice the sulfate stays in solution. Now, be careful. In an exam, they might ask you what you observe. And that means what you would actually see. Now, unless you've got supervision, you are not, that's supervision, not supervision, you are not going to be able to see the ions moving. Okay, if you can, let me know, we'll get you tested. But what you can see, and this is what you need to talk about, your observations. What you would see, if there's a metal, in this case copper, you would see that copper being laid down and starting to coat the electrode, okay, the cathode, and you would start to see that layer of copper appearing. At the anode, you would see the oxygen bubbles. So you would say you can see gas bubbles. Now, you wouldn't be able to say that they were oxygen bubbles. You might get away with that, but realistically, you don't know they're oxygen until you test them. But you would see physically bubbles appearing. You would also note, even though you can't see it for sure, but you might note that there's the hydrogen sulfate which stays in solution. How do you know it's hydrogen sulfate, not sulfate hydrogen? Well, it sounds better. Okay, so this electrochemical series is really difficult, and of course, it's actually wrong. Okay, it's just pants. So I'm going to give you two more golden rules, hopefully to make your life easier. So when it comes to the cathode, okay, and this is what you can write down in your notes. When it comes to the cathode, you are always going to make hydrogen, okay, because look at how lower down it is on this series. It's almost always going to be the least reactive. It's so therefore the easiest to discharge. Now, the exception to that is the copper, gold, silver, or platinum. So basically copper or any jewellery metals. Okay, so the golden rule at cathode is you will always discharge hydrogen unless you have copper, gold, silver, or platinum. That to me is a lot easier to remember than that whole list there. Now, I have never seen a question on gold or platinum. Copper is the most obvious one. They do talk about copper a lot, copper sulfate, and they do sometimes talk about silver. So I've seen questions saying silver is extracted in a similar way to copper, and then they ask you about extracting it. So that's the golden rule for the cathode. Always going to be hydrogen discharged unless you have copper. I'll keep it simple, copper or silver. Now the anode, again, this is really unhelpful, this series here right now, because it doesn't make any sense. So I would almost ignore that chart there, the table. At the anode, you're always going to discharge oxygen every single time, unless there is a halogen or a halide, a group 7 element. Okay, and that's why that table doesn't make any sense there. Ignore it. Okay, so you will always discharge oxygen unless you have fluorine, chlorine, iodine, bromine, or astatine. How would you remember what group 7 is? Well, you don't need to. You will have a periodic table. So just double check. If you've got chlorine, chlorine will be discharged. If you've got iodine, iodine will be discharged. If you do not have a group 7, it's always going to be oxygen. So why is oxygen discharged and not the hydroxide? Well, hopefully you would recognise that hydroxide is made up of oxygen and hydrogen, and the hydrogen is positive. So when it's attracted to the anode, what actually happens is they split up. So there you go. The oxygen is attracted to the anode, and the hydrogen actually then kind of goes back into the solution and probably heads towards the cathode realistically. Okay, so final bit then, guys, redox reactions and half equations. So redox meaning reduction and oxidation reactions. Okay, so redox reactions, reduction and oxidation. We're going to get both, but we need to know why. So let's have a look. Let's start at the cathode. So we need to remember that anything that conducts electricity will have free electrons, because that's why they conduct electricity. Or in the case of the electrolysis, we have a free ion, or an ion that is free to move because it's charged. So it's going to move towards the cathode. Now, when it gets to the cathode, it wants to, I should say wants to, you know what I mean, it will become an atom again. Now, how do I get a positive ion to become a neutral atom again? Well, it's going to gain 2 electrons from that cathode. So that cathode has got lots of free electrons, and it's going to give up 2 of them in order to join with the copper and make it copper atom again rather than a copper ion. So if I think about redox, and if you should remember the oil rig idea, oxidation is loss of electrons, reduction is gain of electrons. This is a reduction reaction. Where has it gone? This is a reduction reaction. There we go, because it has gained electrons. Now, for higher, you would need to be able to draw that, what we call half equation. It's half because the other half is going on at the anode. So how would you do that? Well, it's all about becoming the atom again. So I start off with the ion, Cu2+. I am adding 2 negative electrons to become an a copper atom. You would write Cu2+ plus 2e minus arrow Cu. Okay, now I've rushed through that very quickly. You need to let me know if that's going over your heads. What about the anode then? Well, again, we know that anything that conducts electricity must have free electrons, or in the case of electrolysis, the free ion that's free to move and carry an electrical charge. The oxygen is going to move to the anode. Now, it already is a negative. If it gains more electrons, it's going to become even more negative. So in reality, what happens is that the oxygen gives away those 2 extra electrons to become an oxygen atom. Is it oxidation or reduction? Well, it's lost electrons, so it's oxidation. And what would that look like? So O2 minus, there's the ion, losing or taking away 2 negative electrons, making an oxygen atom. What you would write is that. Now this is where they trip you up, because oxygen or hydrogen or any of the halogens, so group 7, are 2. So this is O2, H2, Cl2. So that's oxygen, hydrogen, and any of the halogens, group 7. Now, of course, this is no longer balanced, so you'd have to go back and say, well, okay, if I'm going to get 2 oxygen atoms, I need 2 oxygen ions, and I'm losing a total of 4 electrons. So that is the balanced half equation for that reaction there. So let me just bring up a slightly different way of looking at it. So the half equations here. So here I've got sodium, and I'm going to add a negative electron to become a sodium atom. And I've got 1 sodium atom discharged. And in this example here, I have got chlorine. So I'm taking away, because it's already negative, I'm taking away a negative electron to give me a chlorine atom. However, I know it should be Cl2, so I'd need to go back and balance that out. And I'd end up with 2 atoms of chlorine discharged. That's as fast as I can do it. Well, it's as clear as I can do it in the speed I've got, guys. If you're struggling, go look at YouTube or ask me for help before the exam. Okay, guys, if you want to pause the video and have a go at this, do it now. Okay, very quickly, guys, because I'm running out of time on my YouTube video thingy bob. That's going to be electricity. This one I'm whizzing through. You'll notice I'm bugging the question. All this information it's giving you, that's going to be the answer. Chlorine. Here I'm giving a reason for 2 marks. I've got to say 2 things. There you go. And this last one here, we're gaining, so it's going to be reduction. Pause the video here, guys, if you want to have a go. And then let's go. So explain again for 2 marks. There we go. Again, give a reason. We're explaining. Looking at experiment 1 for 3 marks. There you go. Sorry, very quickly, I am running out of time. They only let me have 15 minutes per video, and I talk way too much. Notice that one there was a gas produced. If you're writing copper for that, no, or magnesium, no, it's a gas. There we go, and there we go. Right, guys, that is it. I'm hoping that's been helpful. Ask questions if you're not sure, and I'll see you later.